Um, this section, we're going to learn about scatter plots and lines of fit. A scatter plot is a graph that shows the relationship between two data sets. So down here, you can see a relationship between the number of grams of sugar in a smoothie and the number of calories in that smoothie. And you can see there are these dots scattered around the graph. And that's why this kind of graph is called a scatter plot. And so these kind of two related sets of data in this example, grams of sugar and calories, are graphed as ordered pairs. Um, so if we look at a scatter plot and we just work on trying to interpret it, what do the dots mean? How do we read this? Um, some of the kinds of questions you can be asked about a scatter plot is how many calories are in the smoothie that contains 56 grams of sugar? So if we come down here and find where 56 grams of sugar is, and we kind of go up and find what point is there at 56 grams of sugar, um, then we can go to the side and read the y value that corresponds to it. In this case, 270. So the smoothie that contains 56 grams of sugar has 270 calories. So basically what I'm doing is I'm finding the point that has the requested x value, and then I'm drawing an imaginary horizontal line over to find the y value that corresponds to that. You can go the other direction as well. So you can be asked about 320 calories. Well, calories are here on the y-axis and 320 is up here. So we'll read to the side to get to the data point. And then we want to find the x coordinate because I'm asked for how many grams, and grams is down here on the x-axis. I'm going to just read down and see what number is on the graph here. In this case, 70 grams of sugar. Um, Another thing you can ask about is what tends to happen to the number of calories as the number of grams of sugar increases. Well, here I can see when I have few grams of sugar or fewer grams of sugar, the calories are generally low. And then when I get up to higher grams of sugar, the calories are generally high. So I would say that uh, as the number of grams of sugar increases, I would say the number of calories also increases. Okay. So I'm interpreting this graph in terms of the actual labels on the x and the y axis to say how those two variables seem to be related to each other. Now, the next thing we need to learn here is about correlations. And there are different, it's just a relationship between data sets. We've only learned about straight line relationships so far. So these are all linear correlations that we're talking about here. Positive linear correlation is when the data appear to be in a straight line with a positive slope. So there's a general positive slope here, basically meaning as x increases, y increases. You can have a straight line slope where as x increases, y decreases. The general trend is to have this negative slope, which is called a negative linear correlation. You can also have no correlation at all. The points don't show a pattern. They don't seem to be on a line or near a line format at all. And so going back up here and looking at this calories and sugar graph, I would say that there is a positive correlation between the grams of sugar and the calories in the smoothie. So let's look at a couple other graphs and see if we can interpret whether they are positively correlated, negatively correlated, or not correlated at all. So here we have a relationship between a person's age and the number of vehicles that they've owned, or number of vehicles currently owned, apparently. And there's no correlation here uh, between the age and the number of vehicles owned. So that's what we say. No correlation. There's not it doesn't seem to fit a line, um, not a line that has a positive slope or a negative slope. So we say no correlation. Here, however, the temperature and coat sales at a store, it appears that as the temperature increases, the coats sold per day decreases. So when it's cold outside, people are buying more coats. And then when it's warm outside, people aren't bothered about buying a coat. Because the kind of general trend here is downwards with that negative slope direction, this is a negative linear correlation. Linear because those data points are close to a line. So let's look at how to handle scatter plots and interpret them kind of starting from scratch. In these examples, I gave you a graphs and we interpreted them. Now let's do the graph ourselves. So here we have some data that show the total number of subscribers to a video sharing website X years since 2010. We saw this in the last section. When we're dealing with years, here we seem to really care about 2010. Maybe that was the year the website was founded. Maybe that was a significant year for some other reason. But here we don't care about going all the way back to zero in terms of our data. We're only starting at 2010. So we're going to go ahead and label the x with that year since 2010. So 2010 is year zero. And then looks like we go up to 2018 in terms of our data. So write an equation that models the total number of subscribers as a function of the number of years since 2010. And then interpret the slope and intercept of the line of fit. So I'm given a whole list of data points, and so I'm going to go ahead and put them on the graph. So 0, 9 is about here. 121 is about here. 226 is a little bit higher here. 333 is about here. 443, 553, 671, just above the 70 mark. 7 and 76 would be about there. And 8 and 89 is about here. So those are my data points, and they do seem to be roughly linear. And so I'm going to go ahead and try to draw a line of a line of fit that matches my data. Now, a line of fit is just a line drawn on a scatter plot that is close to most of the data points. Close to most of the data points. It can also be called a trend line. Basically, I want to have about the same number of data points above the line as I have below the line. In the next section that we do, we'll talk about a line of best fit. This is just a line of fit. We're drawing it by hand. We're not expecting it to be perfect, but we do expect it to be reasonable. So if I kind of imagine here, I'll start here and try to draw a line up to here. And let's see, I want to have about I don't have, if I'm drawing a straight line here, I don't have a lot of choices of where to put the trend line. So that seems about the best I can do. Let me try one more time. That's slightly better. I think I like my green line better than my purple line. So how do we use this trend line uh, or how do we determine the equation of this trend line? This is just like what we were doing in the previous module, the previous section. We have 2 points on our trend line here that seem to actually be on the trend line. Your trend line doesn't actually have to go through any points on the graph. That being said, it is easier to, if your trend line goes through two of the points. So I've kind of picked this point here and this point here that my trend line goes through, um, because then I know the exact coordinates from those points and I'm less likely to make a mistake with reading the graph. So if I have 2 points on the line, I can calculate the slope between them. So I'm going to do the slope is y2 minus y1 over x2 minus x1. And so that's 76 minus 9 over 7 minus 0, which gives me 67 divided by 7 works out to be 9.57 as our slope. Remember, in case you do get asked, slope has units. Because slope is rise over run, the y direction, change in the y direction over the change in the x direction, then slope has units of whatever your y units are, in this case, subscribers, per whatever's the units are in the x direction, which is years. So this is giving me subscribers per year. Basically, I know that I'm increasing by 9.57, sorry, I should say million subscribers per year. So I now need to figure out the full equation so I can interpret the slope and the y-intercept. So I'm going to go ahead and use point slope form like we learned from the last section. Y minus y1 equals m times x minus x1. And I will just choose a point here to plug in. Y minus 76 equals my slope, which is 9.57 times x minus x1 is 7. I need this to be in slope-intercept form, so I'm going to do the distributive property here. 9.57 times x is 9.7x minus 9.57 times negative 7 here is 66.99. And I still have y minus 76 on the left side of the equation. And now to get y all by itself, I add 76 to both sides of the equation. And I get that y equals 9.57x plus 9.01. Now, when I started doing this point slope form, you might have wondered why I was doing that when in fact I was given the y-intercept. I used the y-intercept in my slope. I just wanted to demonstrate that it doesn't matter which point you use, you should end up with the same equation. Now there's a slight rounding error here. It's not exactly 9 is the y-intercept, it's 9.01, but it is pretty close. So even if you had just decided to use the slope and the y-intercept value, you would have gotten y equals 9.57x plus 9, which is obviously very close to the equation we got, just a little bit of a rounding error there. To answer the question, interpret the slope, we've actually already interpreted the slope. We said that 9.57 is the how many million subscribers we add each year. So this is the meaning of the slope. What's the meaning of the y-intercept? The y-intercept was how many subscribers we had at year 0. Year 0 is 2010. So the meaning of B, the y-intercept, is that we started with 10 million subscribers in 2010. So this is how we draw a scatter plot, how we insert a line of fit, and interpret the slope and intercept of that line of fit. I hope this helped.